Hello and welcome. The topic we are dealing with today is called acids, bases and salts, and we are going to focus on, for this video, making soluble salts. Now the first thing to remember that when we use the word salts in chemistry, we're not just talking about the everyday type of salt that we talk about, the type of salt you put in your food. Salts actually means a whole range of compounds that we can produce in a variety of ways. Now the first way that we can do it is by reacting an acid with a metal, and when we react an acid with a metal, if the metal reacts, if it's reactive enough to react, we will get a salt and hydrogen. And the name of the salt that we get depends very much on the acid or the metal that we use, and we're going to find out how we actually do work that out later on in this video. It's also important to remember that some metals are so reactive, for example sodium, potassium, that if you reacted them with metal or with acid, they would be could be quite dangerous, quite explosive. Some metals actually don't react at all. Something like gold, very unreactive, so is unlikely to react with acid, but a lot of metals we can use and they will produce salt and hydrogen. The next method is acid plus insoluble base. An insoluble base is a substance that's not soluble in water and it's alkaline in its nature, and when we react these two together we get salt plus water. And similarly, when we react acid with alkali, this would be a neutralization reaction, but when we react those two together we also get salt and water. Now I want to go through two methods we could use to make our soluble salts, and we're going to start off with the method of using acid plus insoluble base. So here we have our little formula here that tells us what we get produced with our acid and insoluble base, but we're going to use a particular example. I'm going to use the example of copper oxide, which is our insoluble base, and our acid, which is going to be sulfuric acid. So when we react these two together, the soluble salt that we get is actually called copper sulfate. And what we do is we add the copper oxide to our sulfuric acid and it will react together and produce this copper sulfate. Now we want to get as much copper oxide reacting as possible with the acid, so what we do is we don't just put one or two spatulas in, we actually keep adding copper oxide and we warm the mixture until we can see that no more reacts, and we know no more is reacting because there's still some of the copper oxide left at the bottom of the container. And once we see that, after we've warmed and stirred and added copper oxide, we know that no more is reacting, so we can carry on with our next step. The next step is to filter our solution. So we filter it through some filter paper, and what we'll see is the copper oxide will be left in the filter paper and the copper sulfate solution will go through into our flask. The next step after that is to actually make the salt into crystals, and we can do that in a two-step process. We can add the copper sulfate solution to an evaporating dish, and if you just fix it in place above a beaker of hot water and heat the water, or a beaker of water that's heated, it will cause the copper sulfate to evaporate off a little bit. We evaporate it down to about halfway, and then we take our evaporating dish, put it somewhere near a window or something, and we let it sit there over a few days. And after a few days you will see copper sulfate crystals, and this is our salt that we have produced by adding a acid to an insoluble base. Okay, so this is method one. You do need to know the steps. It looks slightly complicated if you look at it like this, but really it's just reacting the insoluble base with the acid, making sure as much reacts as possible, filter it, evaporate it down a little bit, and then leave it over a space of a few days in order for it to be able to form the crystals. The next method that we're going to look at is adding an acid to an alkali, and that, as we said, also produces salt plus water. And what we have here is a flask with some alkali in it and some indicator. This is actually a universal indicator, and this tells us whether the substance is acid or alkali or neutral. And this purpley color with universal indicator will tell us that it's alkali. We measure out how much we want. So we've got 20 centimeters cubed here of our alkali, and to that we add some acid. And what we want to do is we want to get that solution to be absolutely neutral. So when it's neutral, it's green in color, and it goes green because of the indicator, and we keep on adding our acid until it goes green, and we have to measure the exact amount of acid that we add, and once we see it go green, we know it's become neutralized, and we will have a value for the amount of alkali that we've used, and we'll have a value for the amount of acid if we've measured it correctly. What we then do is we repeat the experiment, but this time we don't add the indicator, we do it without the indicator, and as we know exactly how much acid to add, we can just add that acid and we know that the solution is now neutral. What we do next is similar to what we did before. We would put the solution into an evaporating dish and heat it above some water to evaporate it down a little bit, and then leave this for a few days on the side to form into our crystals of our salt. Okay, so this is the method for using acid and alkali. It's important that you know this method step by step. Okay, so remember, we add known amounts of acid and alkali together so that we can see how much it takes to neutralize it, take our indicator out, add the two amounts together, we know it's a neutral solution, and then we can just carry on as we did before. Now the last thing I want to go through is very important. It's about predicting which salt is going to be made when you react certain acids and alkali or metal together. Now you need to know that when you are using hydrochloric acid, you are going to make chlorides, so you will make something chloride depending on what you react with the hydrochloric acid. If you use sulfuric acid, it's going to make sulfates, and if you use nitric acid, it's going to make nitrates. Okay, so how does that actually look in an example? Well, here's an example of a question. If we have hydrochloric acid and we add magnesium to it, we know that acid plus magnesium produces a salt plus hydrogen. You need to be able to name the salt that's going to be made here. Well, we said hydrochloric acid makes chlorides. That's very simple. We've got hydrochloric acid there. We'll just add chloride there because we know it's going to be something chloride. How do we know what chloride it is? Well, it's just going to be the metal that we put in front of the chloride, and it becomes magnesium. Sorry, not able to fit that in, but it's going to be magnesium chloride plus our hydrogen. What about sulfuric acid? Well, let's have a look at an example. If we have sulfuric acid plus copper oxide, and that's the first example we did a couple of slides back, we know we're going to get sulfates because sulfuric acid makes sulfates, so it will be something sulfate. And what exactly sulfate will it be? Well, we take our copper from our copper oxide and it will be copper sulfate. So adding sulfuric acid to copper oxide will give us copper sulfate plus some water. Similarly with nitric acid, we've got nitric acid and sodium hydroxide. We know that nitric acid makes nitrates, so it will be something nitrate. And we take the sodium from the sodium hydroxide from our alkali, and it will then be sodium nitrate plus water. Okay, now it's important that you actually know and remember these blue boxes. You have to remember those. Those won't be given to you necessarily in the exam, and you can use those three to work out which salts you're going to make. It's quite straightforward really. Hydrochloric, chlorides, sulfuric, sulfates, nitric, nitrates. Right, just to go to more of a exam style question, which salt will be produced if we reacted hydrochloric acid with potassium hydroxide? Well, we know hydrochloric acid will make chlorides, so it's something chloride, and we've got potassium here, so it's potassium chloride plus water. This says which acid and alkali, by that we mean a metal hydroxide, could you react to make magnesium sulfate? Well, to make sulfates we know we need hydrochloric acid. No, we don't. We need sulfuric acid. Sulfuric acid will make sulfates. And which metal hydroxide do we react? Well, it's magnesium sulfate, so it's going to be magnesium, and it tells us it's a metal hydroxide, so it's magnesium hydroxide. Okay, and the last one, which metal oxide could you react with nitric acid to make iron nitrate? So we want nitrate, so it's going to be nitric acid. And metal oxide, well, we want iron nitrate, so the metal is iron, so it will be iron oxide. Okay, so this is just slightly more in the form of what you might see in the exam. You are required to know which chemicals make which salts, and this is just an outline of how you might do it. So thanks for watching, and see you again soon.